Hello everyone, so it's good to see you all again. I'm Natasha and welcome back. So today we're gonna do a new chapter. So we'll be discussing about a new chapter and it's the 5th chapter. It's complex numbers in quadratic equations. So we're not gonna discuss about quadratic equations. So overall, we'll be discussing about complex numbers first and then we'll move on to quadratic equations. But before that, let's understand about complex numbers. What are complex numbers? Why do we need complex numbers? How can we represent complex numbers? And what is the use of complex numbers? Yeah, so we'll be discussing some of these few questions, or maybe all of the questions. So, and yeah, we'll be I think we'll be also discussing about the Cartesian form of complex numbers. So of a complex number, yeah. So let's get started. So we have a lot of things to discuss today. So let's finally just let's start it. Yeah. So complex numbers. So first of all, we'll have to know the first questions coming what are complex numbers? Okay. So what are complex numbers? So any number of form a plus iota b. Okay. So I just said a word, iota. So it's a new word for us. So before discussing what are complex numbers, I want to discuss that why do we need complex numbers? Because I think through that topic, through that question, we'll be able to understand about complex numbers. So let's just first discuss that why do we need complex numbers? Our normal world was really fun. We just had to study about the real numbers, but what are complex numbers? So first I'll show you something in a Venn diagram of the numbers, all the numbers. So Venn diagram of number sets. Venn diagram of number sets. Got it? Okay, so first thing that comes is the natural number, isn't it? Natural number, in which it starts from 1, isn't it? And the second one which we have is, what do we have? Whole numbers. In whole numbers we have 0. And then, it continue. Then after the whole numbers we have integers. Yeah, we have integers. So, after the integers, what do we have? Okay, so in the natural number we have the numbers, starting from 1, so counting numbers like 1, 2, 3, and so on. So, and in whole number, we have one extra number, and that is 0. So, in whole number, it starts from 0, and the integers in which we have the negative and the positives too. Okay, so the fourth one is going to be, let's guess, what is it going to be? Of course, it's going to be, guess what? It's going to be rational numbers, of course, rational numbers. Or are we forgetting something? I think it is rational number, isn't it? Yeah, it's going to be actually rational number. Yeah. So after the integer comes the rational numbers. And then we have a different number, which is irrational numbers, okay? It's not related to rational number. So I can say that, natural numbers comprise of whole numbers. So I've just, drawn them in a same circle, but irrational is not related to any of these numbers. So, but yeah, and all these numbers make the real numbers, isn't it? Yeah. But yeah, there is one more number that is the boss of all these numbers. I can say that's a king, not the boss. Yeah, king. So, which is the biggest one? And it is complex numbers. Of course it is complex numbers. So complex numbers. So we'll be discussing about complex numbers. So first thing that why, what was the need for using complex numbers, and why was it invented, all those things, why was it discovered? So it was mainly discovered to, find some things which real numbers cannot. So as we have seen that in real numbers, square root of a negative number is not defined. But now in complex numbers, square root of a negative number is defined. So complex numbers are, basically like they're used to find the square root of a negative number, which real numbers can't do. So that's why we're using complex numbers. So I hope you have understood about the complex numbers. So I'm gonna write some few things here. So let's start. Oh, wait a second. I don't want to fall. Yeah. Okay. So complex numbers. So first thing is, in real numbers, square root of a negative number is not defined, as I've already told you. So let's take an example. So for example, yeah. Okay, so I'm going to say that prove that x squared plus 1 is equal to 0. Okay, when we're not aware of complex numbers, we always thought that this equation is not true. But yeah, now this is going to be true. It's just going to be because of the complex numbers. Got it? So x squared plus 1 is equal to 0. It is equal to 0. Now let me tell you how. Okay, so yeah, I was saying that x squared plus 1. So let's say that we have the value x squared. Okay, so what I'm going to do is I'm going to write it in a really simple way. So just have a look at the question, then we'll move on. Okay, so what is this given to us equation? Is an equation x squared plus 1 is equal to 0, which is not which is not actually true for real numbers, but it is for complex numbers. So I can say x squared plus 1 is equal to 0. It's just because of complex numbers. So now let's try to understand how is it. How is it? So how is it because of complex number? Okay, so let's say this x squared is gonna is equal to, so x squared is equal to negative 1. How? It's just really easy. The positive 1, which was on the, with x squared, I just, shifted it on the right hand side, and of course the signs are going to get changed, so I got negative 1. So what I got is x squared is equal to negative 1, and that's it. So this is actually going to be a value, but we're not exactly sure. But if I want to remove the square on the left, on the right hand side, we can't say that x is equal to, under root negative 1. Under root negative 1, isn't it? But we can now. We can actually. We were actually not aware of complex numbers, so that's why, we have been saying that this equation, these type of equations are not true. Okay, so we can't prove it. But we can prove it now because there is a complex number. So x is equal to plus or minus. So I don't know if it's going to be, who knows that is it going to be positive or negative? So we don't know about it. So I'm going to use the plus minus sign. Okay, so this negative 1, the root negative 1 has another name, which is iota. So I can say this root negative 1 is, denoted by a symbol I. Is denoted by a symbol I, which stands for iota. So this I stands for iota, and iota is a part of complex numbers related to the imaginary numbers, imaginary part. Okay, so we're gonna we'll be also discussing about the real part and the imaginary part too. Okay, yeah. So negative 1. So what I'll say, so in the box I'll say this. So the solution of this equation is plus minus I. Okay, we can also say it I, and we can also say it as iota. So the solution of this equation is plus minus I. Okay, if we can't write if we cannot write the root -1, we can also write, but yeah, we can write actually, because as if we're going to write I, then we can also write root -1. But we're actually obviously we're going to use I always. Okay, so what I'll say is x is equal to plus minus iota, isn't it? Yeah. So for this example, I proved that this equation, these type of equations can be true. It's just gonna be through the complex numbers. Okay? Yeah. So is it clear? So I hope you've understood all about complex numbers. No, not everything about complex numbers, but then what is the need? What is the need for complex numbers? So I think that will be clear. Now we'll be discussing about that. What are complex numbers? Okay. So what are complex numbers? The question comes, what are complex numbers? Complex numbers. Okay, what are complex numbers? So I'll write any number of form with wait a second. Yeah, any number of form. I'm just directly going to write the form. Yeah, so any number of form a plus ib, and this I is iota, so a plus ib where a and b belongs to the real numbers. Any number of form a plus iota b where a and b belongs to real numbers are complex numbers. Okay? Yeah, so I hope this is clear to you. This is just a short definition, a statement for complex numbers. Okay? So any number of form a plus iota b is a complex number. So let me just change it. Let's talk about a single complex number. So is a complex number. Okay? Let's just use this all singular things. So what is a complex number? This is more better for now. Okay? We shouldn't be discussing about this thing. So what is a complex number? Any number of form a plus ib where a and b they're real numbers. So any number of form a plus ib is a complex number. One thing you have to remember that this a and b, they both belongs to the real numbers. Okay? So, complex numbers are, made up of imaginary numbers and the real numbers. And, if they're merged and if they're combined, then we get this complex. Complex, we can, just guess it by the word complex. Complex, isn't it? So it's just combined. So this is how it's making complex numbers. Okay, so now this is also clear that what is a complex number. Now let's discuss that what is the use of complex number. So I think I've already told you that this complex numbers are used to find, they're mainly used to find the square root of a negative number, okay? Because it's not possible in real numbers, so that's why for the complex numbers, so complex numbers are mainly used to find the square root of a negative number, okay? So next thing, that how do we represent complex numbers? So complex numbers are usually represented by, letter Z. So complex numbers are usually represented by letter Z, but it's not I don't think that it's fixed or it's permanent, it's mandatory or anything. No, it's not. Actually, I think that we can use any other letter too, like A, B, C, D or any else, okay? But yeah, it's usually represented by Z. So it will usually be in the form of Z. Got it? Yeah. So now let's talk about the Cartesian form of complex numbers. Okay, so is there any need to just clean the board or... Okay, I guess that I'll be able to... Okay, I'm going to rub it. Yeah, I'm going to just clean the board, so let me clean this off and then we'll continue. Okay, so then we'll be discussing about, okay, there's some few things I want to tell you before moving on to our Cartesian form of a complex numbers. So one thing that all real numbers are also complex numbers with imaginary part 0. What does this statement mean? Let me give an example. For example, 2i. 2. Let's say 2, okay? How am I going to write this in the form of complex number? How? It's just really simple. I'm going to write this 2 plus iota 0. And this is how I'm going to get it in the complex form. It is in the complex number. In the form of complex number where 2 and 0 both belongs to the real numbers. Isn't it? And the imaginary part is 0. Yeah, I'll be talking about the imaginary part and the real part in Cartesian form of a complex number. So, that's what I wanted to tell you. So, all real numbers, there are also complex number. How? It's just with the imaginary part 0. So, all real numbers are also complex number with imaginary part 0. Okay? Yeah. And the second thing I want to tell you is related to complex number and real numbers. So let's see what is it. So a set of real numbers is a subset of set of complex numbers. So what I'll say is the set of real numbers is a subset of set of complex numbers. Yeah, it is true. It is true, yeah. So set of real numbers. So, the set of real numbers is a subset of set of complex numbers. Okay, yeah. So, we'll be proving this also. We'll be proving this too, but I don't think there's any need. So, for now, we'll be not discussing about this thing. So, we, that's all we had to discuss before, discussing about a topic Cartesian form of a complex number. Okay, so let me just clean the board and then we'll be discussing about the complex form of a complex, was I saying complex form? I think so. No, it wasn't complex form. I was saying Cartesian form of a complex number. Yeah, so, we'll be discussing about the Cartesian form of a complex number. Okay? Yeah, so I'm almost done. I'm not going to interrupt this. I just need a little bit of space, so I'll be not cleaning everything. So, the complex number is in this form, a plus ib. Just have a look. Z is the complex number. So, it's defining a complex number. So, Z is equal to a plus iota b, where b, so one thing we always have to remember where a and b both belongs to the real numbers. And the second thing, if we're going to talk about the real part of z, what if I want to know the real part of z and the imaginary part of z, then what is it going to be? It's really simple. It's going to be, the real part of z is going to be a, okay? And the imaginary part of z is going to be b. Many of us think that the imaginary part will be ib. No, it's not. Actually, I is just a symbol. I is just a symbol, it's nothing, so it's not related to the imaginary part. But if we're going to talk about the imaginary part of z, of the complex number we're having, so we're just going to have a look at that, at that number which is with the, this I symbol. So I can see this b is with this I symbol, so which means that b will be the imaginary part. But this a will be the real part, as it's not with I. Okay, so that's it. And let's take an example. Let's take a small example. So, in which I have to, in which we have to tell the real part and the imaginary part of z. Okay, so I'll be using some numbers, constants, So, write RE. RE is, the real part of z. And IM. IM is the imaginary part of z. of z is equal to 3, negative 3 plus 2i. Okay, just have a look. So this is the question, and now let's solve it. So this is really an easy question. Okay, so the RE, so it's in the math form. I'm going to write this thing, not a statement in like this way. So REZ, so the real part of z is going to be negative 3. And if we're going to talk about the imaginary part of z, then it's going to be 2, not 2i. Okay, so this is very clear to the through this small example. So I hope like everything's clear to you. And that's all for today. In the next video we'll be discussing about the algebra of complex numbers, in which we'll be discussing about the addition of complex numbers, subtraction, multiplication, and division. So there's a lot of, and some of their laws too. So we'll discuss all these things in the next video, or maybe in another video, I'm not sure. So that's all for today, and I've already told you that. So what we'll be doing in the next video. So thanks for watching, and have a great day.